So today here on campus, we did some enrichment problems. Again, working on some synthesis type problems. As we continue to add reactions to our list of reactions that we know a lot about, I try to include both old reactions and new reactions in our enrichment problems that we do. So if you're an online student, you can go to the course website and download this file and try it for yourself, and then look at the answers when you're ready. Or if you don't want to go to the course website and download the file, or if you don't have access to it, just pause the recording, try these for yourself, and then hit resume when you're ready. So there are 10 problems. Here are 1 through 3. There are 4 through 6. There's 7 through 9. And then there's number 10. Now again, the goal here is these are the desired molecules. This is the molecule I want. So you give me the name of this molecule, and then also tell me what kind of reaction would produce it, and write a reaction for that. So now we're going to go over these problems here on campus and see what we came up with. And I'm gonna make my spacing a little bit bigger here, so I've got room to write. There we go. Actually, that didn't really help, did it? Whatever. I'll just hit enter a whole bunch of times, I guess. I love it when Word thinks it's smarter than me. Okay. So first of all, we want to name the molecule, and then we want to identify the type of reaction. So this is one of the molecules we've done most recently, but there is a slight little twist on this. What kind of molecule is this? What functional group does it contain? It contains an ester, right? It contains an ester. And so when we're naming ester, we have to identify the part that came from the alcohol and the part that came from the carboxylic acid, right? So which part came from the alcohol? Right, this part came from the alcohol. Right, and then this part came from the carboxylic acid. And then when we put the name together, which part goes first, the alcohol part or the carboxylic acid part? The alcohol part came first, right? So there's just, now if this bromo wasn't here, if this were completely not here, what would this be called? Propyl, right? So if that bromo wasn't there, we'd call it propyl. But since there is a bromo there, we're going to treat it like it's on carbon 1. So we say 1 bromo propyl. And then is there anything different here? No. So the name of this is, instead of propyl, what's the second half called? 1, 2, 3, 4. Butanoate, right? It's not butanoic acid because that's a carboxylic acid. It came from butanoic acid, but the name would be propyl butanoate, right? Because when we name an ester, that's the suffix is OATE. So the name is 1 bromo propyl, and then 1, 2, 3, 4 butanoate. Right? The OATE suffix is for an ester. Does that make sense? And so the reaction that would produce this has what name? Esterification, right? Because that's a reaction that produces an ester. And so what we do is we take our carboxylic acid. So that part's easy because we just broke it down to name it. Right, so that's butanoic acid plus, now again, if that bromo wasn't there, what would it come from? Right, 1 propanol, right? But because, 1, 2, 3, but because it's 1 bromo, right, what do we need? we need to have a bromine on there as well, right? And so where does the bromo go? So we need our bromo on there as well. Make sense? And then that will give us our desired product. Do we agree? All right. Now, I probably wouldn't put substituents on a test, but on these enrichment problems, I like to throw some tougher ones on there because I figure if you can do the harder ones, you can do the easier ones. Let's make this bigger so we can see. Number 2. Okay, what's the name of this? Let's begin numbering first. Do we number from the left? 1, 2, 3, bromo, bromo, or do we number 1, 2, 3, bromo, bromo, or does it matter? It's not going to matter, right? Because either way, you're going to get carbon number 3 having 2 bromines on it. So you can go whichever direction makes you happy. So what's the name?
3, 4, dibromo.
Well, it's not 3, 4, dibromo. Right, 3, 3, 4, 4, tetrabromo, right? Tetrabromo hexane, right? And then how are we going to make this? What reaction would give this to us? This is an oldie.
The addition of 2 PRE.
Right, what's the name of that kind of reaction?
Oh, alkyne
halogenation, right? The category would be halogenation. So we would take 1, 2, 3, 4, 5, 6, and between 3 and 4, 1, 2, 3, we need our alkyne, right? Plus 2 Br2. Don't forget that coefficient of 2. Why do you need 2 of them?
because it's an alkyne.
Right, the first pair will give you 1 on each, and then the second pair will give you the second. And then that'll give you your desired product. So that's one of the first reactions we talked about. We talked about alkenes and alkynes. Any questions on that one? Doing good? All right, let's look at number 3. There we go. Put our cursor way up here. Okay, let's name this. All right, now this is what functional group is involved here? Carboxylic acid. And how many of them are there? There are 2, right? And so this is called a dioic acid, right? Now, if there are no substituents, does it matter which one's number 1? If there are no substituents? No, there aren't. There's no, who cares? But because there are substituents, we need to number to give them the lowest numbers possible, right? So are we numbering from the left or from the right? From the left, right. 1, 2, 3, 4, 5, 6, 7, right? So then we've just got to put our substituents first. So the name of this would be what?
3, 3, 5.
Well, it's 2 chlorines, right?
Oh, yeah.
So it would be 3, 5 dichloro. Right, 3 methyl. And then what?
Is it heptadioic?
Heptane dioic acid, yes. So how do we make carboxylic acids? I've only taught you one way to make a carboxylic acid. I mean, I would accept 2 answers. Reaction that would work, but they're both from the same class?
Oxidation.
Oxidation, right? So you could either oxidize of a dial, right? That's a dialdehyde, or of a diol. Either one will work, right? Because diol oxidized to a dial, which then further oxidizes to dioleic acid. So if you want to work backwards, right? Let's work backwards. So what dial would give me this? We start right here, right? Carbon number 1, 2, 3. Try not to stand right in front of the camera. Cl and a methyl. 4, 5 has a chlorine. And then 6, and then 7. Right, there's the aldehyde oxidation, right? And then if I were to oxidize an alcohol, OH, and then Cl, Cl, OH. If I oxidize that, that gives me that, right? Which then oxidizes to that. Do we agree? That's what your alcohol looked like?
Yes, except I forgot to put the substituents on it.
Oh, okay. Yep, got to carry those along with it too. But if you start with the alcohol, once you get the aldehyde, that oxidizes really, really easily. So you can get your dial. All right. I tried to throw some ones on there that just really make you think. Because again, I figure if you can do a more challenging one, then if your exam has something significantly less difficult, right, you're just that much better off. Okay, so when we're doing this one, what functional group do we have here? We have what? Ketones, right. And now when we're numbering this, we have to give priority to what? The ketones or that methyl group? Right, so where's carbon number 1? There's only one correct answer.
On the bottom right.
Bottom right, right. So 1, 2, 3, 4, 5, 6. So I would accept 2 names, and I think your online homework would accept 2 names. Right, you could call this 4-methyl, then what?
1,3-cyclohexadione.
Cyclohexadione, right. Or you could also call it 4-methyl. And then what's the other thing we can do if we want to split this up, right? You could put it right here.
Well, on this one you can't put the M, right? Because there's a methyl.
Huh?
Like the M, like.
Oh, no, because this is not a benzene.
Oh, he's like on benzene.
You can only do that on substituted benzenes. Yes. Now I'm talking about, remember I showed you, you could put the 1, 3 in front, which is like what your book does, but some books will put it in the middle. So I think your online homework would accept either one. But this is the way your book would name it. But just so you know the other way to look at it, right? I'm pretty sure your book would use this method though. Now if I want to make this, what way do we know to make a ketone? Mm-hmm. Alcohol oxidation. So what's my parent molecule going to look like?
You have to still have your methyl, and then you have an alcohol on carbon 1 and 3.
Right. And then you can decide what oxidizer you want to use, or just put O in brackets. Good. Feel good about 4? Okay, for 5, what's the name here? Well, where's carbon number 1? Let's do that first. Right. 1, 2, 3, 4, 5, 6. So what's the name here?
1,3-methyl cyclohexene.
Not 1,3-methyl, it'd be 1,3-dimethyl, right. Cyclohexene. You don't need to state where the double bond is in a ring, right, unless there's more than one double bond. Okay, so there are 2 reactions that we've talked about that could make this. What's one? Alcohol dehydration will do the job, right? And so where is the double bond? Let's do reaction number 1. List them out. Alcohol dehydration. And so where does the alcohol need to be?
Because we have carbon 2, like at the one after the methyl.
Here? Yeah. So if you had an OH here, when that thing dehydrates, you'll get double bond here, and you'll get double bond here, right? Because Satsev's rule is going to kick in and say, I want the most substituted alkene, right? So I get here and here. But if I put it somewhere else, then there's only one major product. So that would work, but you're going to get 2 products. Where's a better place to put it where you only get 1?
On the same one as the methyl.
Right. If you put it right here, then Satsev rule, you're going to get, you're still going to get a mixture, aren't you? You're going to get here, and you're going to get here. So yeah, either way, you're going to get a mixture. Now that I think about that. Yeah, both of them would work. You're going to get a mixture either way. Because if you do it right here.
So does that mean alcohol dehydration is not a reaction?
No, it works. You're just going to get a mixture. It's not bad. It's just you're going to get a mixture, right? Because when you dehydrate this, you're still going to get a mixture. You're going to get that, which is what you want. Yep, that will work, plus H2O. And then you'll also get the other version too, right? Because if the double bond is here, is that any more substituted than if the double bond's here? No, so you will get the other one. Which means that, like you said, that one would work too. I just wasn't thinking it through. If you had this, and then you dehydrate that, you will get the product of interest, but you'll also get the other one as well. Now let's think about that. Actually, those 2 are the same molecule, aren't they? 1, 2, 3, 1, 2, 3. So those are the same molecule. So actually, where you had it's the better choice. Yours is the better choice. So, good job. I'll blame my waking up at 3 a.m. today for that one. But, yeah, yours is the better choice. Having it there's the better choice because these 2 are the same thing, right? 1, 2, 3, 1, 2, 3. So those are the same molecule. So, yeah, this is the better choice.
Is the second one Diels?
Mm-hmm. Yep. Now, we don't get into all the mechanism of Diels-Alder. We just look at the overall reaction. So what would you need your diene to look like? You need it to look like, if you're trying to draw it, like what you're, putting the two pieces together. You're going to form a bond between here and here, bond between here and here. This shifts up to right there. Is that what you came up with? All right. Good catch on that one. All right, let's look at number 6. So there's only one reaction we've talked about to make, what functional group is that? Let's name it first. Where's carbon 1? Right, 1, 2, 3. Now does it matter if you go 4-5 or 4-5? Nope. So for fun, let's just do this. So what's the name of this? Pentanal, right? And so how do you make an aldehyde?
You oxidize an alcohol.
Mm-hmm. So if you have this,
So is
1,
the
2, 3.
reaction called aldehyde oxidation?
Aldehyde oxidation, yeah. There you go. You feel good about number 6? All right, let's look at 7. Okay, let's first name it. Where's carbon 1? And do we number clockwise or counterclockwise? Counter, right. So this is what?
The one you have is a 1,3-dimethyl pentanol.
Right. Cyclopentanol, right? Yep. Okay, now when we make this, how do we make an alcohol?
Alkene hydration and ketone hydration. Right?
Well, could you have a ketone right here?
Makes ketones be in the middle. Oh no.
Because if you had a ketone right here, how many bonds would that be? 1, 2, 3, 4, 5. You can't hydrate a ketone for this one. On the next one, you can, but not on this one. Right, the only reaction that will work is alkene hydration. So you're going to get a mix regardless of how you do this, right? Because if you have the double bond here, Markovnikov's rule is going to say you'll get the OH here, right? And then if you have it here, Markovnikov's rule says you're going to get the double bond here. So which one did you go with?
I put it to the right.
To the right? Okay. Either one would work, right? Because they both obey Markovnikov's rule. So either reactant. And don't forget our catalyst. Oops. Will give us the major product of interest. But we could also have it on the other side as well. Markovnikov's rule is still going to apply. Because either way, Markovnikov's rule said OH is going to go here and hydrogen is going to go here. OH is going to go here, hydrogen is going to go there. So either one would work. Now on the next one, which is extremely similar, And that's why I wanted to put two of them that are very similar back to back so you could think about that. Here you can use your ketone reaction. Why couldn't we use it on the previous one though? Well, because if there's a OH here, you can't have a double bond there, right? Let's name it first. Where's carbon 1? Okay, and we're numbering clockwise or counterclockwise? Clockwise. So this is what? cyclopentanol. Good. All right, so there are two reactions that'll give us the product of interest. Which one did you list first? Okay. So where is the alkene? Where's the double bond?
Between the OH and the methyl.
Between the OH and the methyl? All right, so when we get our Markovnikov's rule kicking in, wouldn't that put the OH right here? When you react this with H2O, Markovnikov's rule is going to say, let me rewrite that. Markovnikov's rule is going to say this is going to go here because the hydrogen's going to go here. Is that the product that we're looking for? No. So where does the double bond need to be? Right, it needs to be here because if Markovnikov's rule kicks in now, right? But you're going to get a mixture, right? Because you're going to get a racemic mixture. You're going to get 50-50. Because this has not got one that's more substituted, you're going to get both products. You're going to get a 50-50 mixture of the product you want and another product that you don't want that you'll have to separate out. But that's the only way to do it, right? Because if you put it originally, like where you put it originally, that'll put the OH here, which we don't want. So there's really no way to do this, right, without getting a mixture. You see what I'm saying there? And now what's the other reaction that works? Yep, ketone hydrogenation. So if we take and react this with what? H2, using our palladium catalyst, we get our product of interest.
You have to have H2.
Oh, yeah, you need to keep that. Okay. Number 9. Oh, yes, we've got our fun one. Do you remember how to do this one? Is it an ester? Now, you don't have to name that. It's not got an ester, it's a ether. Right? I told you I wouldn't name, you wouldn't have to name that on the test. But that's an ether. But just for practice, just for fun. Get rid of that now. This is a 1,2 ethoxy. My screen just moved. Right? And this is a ethoxy. And this is a 1, 2, 3, 4. So this is 1, 1, what? Diethoxy. And then it's 1, 2, 3, 4, butane. Again, I wouldn't make you name that on the test. It's just for practice. But the reaction you should be able to do. What reaction produces this? There's only one we talked about. Okay. So this is the aldehyde addition. Remember, that's the two-step reaction we talked about, aldehyde plus alcohol. You get an intermediate, and then your intermediate reacts with another alcohol. So the aldehyde here, 1, 2, 3, 4. There's my aldehyde, 1, 2, 3, 4. Right, and the alcohol that I'm reacting this with is ethanol, 1, 2. Remember, this is the negative part, this is the positive part, this is the positive part, this is the negative part. So this goes here, this goes here. This gives me my intermediate. So 1, 2, 3, 4. We get OH, and then we get O, 1, 2. Remember this?
Yeah.
That's the intermediate. And then we take our intermediate and we react it with a second alcohol. And we get our final product, plus H2O. Do we remember that now? That's the aldehyde addition. Aldehyde plus an alcohol. So the way you do this is you look at the ether, and that's what your alcohol is going to be. And then you look at the parent chain and turn that into an aldehyde, and that's what your aldehyde will be. Make sense? And then we end on an easy note, number 10. What's the name of this? Do you remember from the left or from the right? From the left, so 1, 2, 3, 4, 5, 6, 7. So what's the name of this?
2, 3, 4, 2, 15.
Not 2-heptene,
Oh,
3-heptene, right. And what reaction is going to give us alcohol dehydration? Where is the alcohol going to be?
I don't, is it on the same one as, it's not, is it? It's not on the same one as the methyl?
It has to be here. Let's think about why. Because if we put the alcohol anywhere else, you're going to get 2, 3, right? When we dehydrate this, we're going to get the double bond here. That's the major product. If we have the double bond, if we have the OH here, right, we're going to get the double bond right here. And if we have the OH here, we're going to get the double bond right here. It's going to give us 2, 3. I mean, it's going to give us right here instead of right here. Make sense? So when we kick it right there, we get our product of interest. Oh, we need our catalyst too. All right. So that's where we'll end.